Okay, so the problem asks how many molecules of NO can be produced by the reaction of 65.00 grams of NH3 with 150.0 grams of O2 according to the following balance equation. So I started by rewriting the balance equation, and then I took the information given and I wrote it underneath the respective molecules in the balance equation. This helps me organize my thoughts and also helps me see that this is what's called a limiting reagent problem. So in a limiting reagent problem, we are given the starting amounts of more than one reactant. So we have our amounts of our NH3 and our O2. And we're going to need to determine how much of our product we can make. So we're going to need to convert our starting amount of NH3 to our product. And same, we're going to need to convert our starting amount of our O2 to our product as well. So I've set these two up kind of in tandem. And let's go ahead and start with the NH3. So we're provided the grams of NH3. I only know how to convert from grams to moles using the molar mass, which is about 17 grams per mole. I got that from by adding up on the periodic table. Nitrogen is about 14 grams per mole, and there's 3 hydrogens, each at about 1. So 14 plus 3, I get about 17 grams per mole. Okay, I know that my grams need to be on the bottom so that my units here, grams of NH3, will cancel because they're diagonal. Now that I have moles of NH3, I'm ultimately trying to get to NO, so I can now convert from my moles of NH3 to my moles of NO. And I know what values to put here because I'm looking at my balance equation. So looks like per 4 moles of NH3, I expect to produce 4 moles of NO. Okay, I know we're asked for molecules, but let's just stop there. Okay, if I were to plug this into my calculator, first I want to check, did I set it up right? I'm going to check my units. Moles of NH3 cancel, and I am left with moles of NO. Great. And before I plug that in, let me set up this second one. So we have also oxygen to consider. So I'm going to set up pretty much the same thing. Oxygen, I need to go from grams to moles. I know the molar mass is about 32 grams of oxygen per 1 mole, so 16 times 2 because it is diatomic, O2. And based on my balance equation, it looks like per 5 moles of O2, I expect to produce 4 moles of NO. And again, I knew to set it up like that because now when I think about my units, grams of oxygen are diagonal. Anything divided by itself will cancel, so they'll cancel. So will moles of oxygen. Those will cancel. And I'll be left with moles of NO. Okay, now I'm ready to plug these values into my calculator. I'm going to multiply by everything on the top here and divide by everything on the bottom. So I'm punching in 65 times 4 divided by 17 divided by 4. And so for my moles of NO, I get 3.82. Let's just stick with 3 sigma for now. Okay, down here I've got 150. Again, multiplying by everything on the top, dividing by everything on the bottom. 150 times 4 divided by 32 divided by 5, and I end up with 3.75. Okay, so this means if I started with this much NH3, I could make 3.82 moles of NO. If I started with this much O2, I could make this much NO. And so I compare these two values, and the smaller one is going to be the one that I am going to end up making. This is also called the theoretical yield. And we got this from O2, which is called our limiting reagent. Okay, so now I need to convert this to molecules of NO. So I know that theoretically with these amounts of reactants, I can only make the smaller amount, 3.75 moles, but I need to now convert to molecules. And I know the definition of a mole is just like 1 dozen equals 12, 1 mole equals 6.022 times 10 to the 23rd. So 1 mole of NO is going to be that many molecules. Okay, and sorry it's getting kind of messy here. Let me plug that into my calculator. So I'm doing 3.75 times 6.022 times 10 to the 23rd. And looking at my sig figs, this value has 4, this value has 4, so I'm going to record 4 likewise. I have 2.258 times 10 to the 24th molecules of NO.